This is a plastic bottle. This is an aluminium can. In about 10 seconds, they will go into the same bin, ride in the same truck, and arrive at the same building. By the end of this week, the can will very likely be metal again, sitting in a coil, waiting to become another can. The bottle probably won't be a bottle. There is a good chance it won't be anything. Same bin, same truck, same building. Different fate.
Here's the first clue. In the United States, in late 2025, a ton of baled plastic bottles sold for about $100. A ton of baled aluminium cans sold for around $2,000, 20 times, for two objects that spent the last hour side by side. Recycling isn't one thing that happens to everything you put in the bin. It's a series of gates. Physics, color, contamination, machine vision, and, above all, a price per ton. Each gate treats these two objects differently. So let's follow both of them through every gate and see exactly where their paths split. First gate, the bin itself. This is where most material is lost, and it isn't the machine's fault. In the US, only about a fifth of household recyclables actually make it into the recycling stream. Roughly 3 out of 4 bottles and cans go straight into the trash at home. Our two are the lucky minority. The truck tips onto the floor of a materials recovery facility, an MRF. A large one handles 30 to 40 tons an hour. Nothing here is sorted by intention. Everything is sorted by property. Before any machine, people pull out what would break the machines: hoses, cables, plastic film that wraps around shafts like hair around a drill. Then, the screens. Rotating discs let small things fall through and carry flat things, cardboard, over the top. A glass breaker screen shatters glass on purpose so it drops out as colored. Size and shape, that's all the screens know. A magnet lifts out steel, and then this, an eddy current separator, a spinning magnetic rotor that induces a current in anything conductive and non-magnetic, aluminium. The can is literally thrown off the belt into its own chute. 3 minutes into the plant, the can has already been recognized, separated, and priced. Remember that. The bottle keeps riding. Ahead is the machine that decides plastic's fate, a near-infrared sorter. Every polymer reflects infrared light in its own pattern, a fingerprint. A camera reads the fingerprint at belt speed, and a row of air jets fires in a few milliseconds to punch the chosen item into another stream. PET one way, natural HDPE another, colored HDPE another, polypropylene, if this plant bothers, another. Then a person stands at the end of the line and pulls out what the machine got wrong. Then a baler crushes each stream into a cube the size of a fridge, and that cube has a price. Our bottle made the PET bale. That's the good outcome. Now let's talk about everyone who didn't. Plastic is not one material. It's at least 7 families that don't melt together, and inside each family, color, additives, and shape create subgrades that markets treat as different products. Look at this. 2 milk jugs, both HDPE. In September 2025, the natural, uncolored bale sold for 44 cents a pound. The colored one, under 3 cents. Same polymer, 17 times the price, because pigment can't be removed, and buyers want white. Some things the sorter physically cannot see. Black plastic is usually colored with carbon black, which absorbs near-infrared. To the camera, it's a hole in the belt. It rides to the end and drops into residue. Films and bags jam machinery, so most plants don't accept them. Multi-layer packaging, a crisp bag, a coffee pouch, is several polymers laminated together. No jet can separate what is fused. In the US, polypropylene ends up recycled at single digits. Films around 11%, mixed containers around 5%.
Now put numbers on the whole system. On average, about a quarter of what enters an American MRF leaves as residue, landfill or incinerator. Then the bale goes to a reprocessor and loses more in washing and sorting. The OECD's global picture for 2019: 15% of plastic waste was collected for recycling, and about 40% of that was lost before it became anything. Net, 9% recycled, 19% burned, half to landfill, 22% mismanaged, dumps, open burning, the environment. You may have heard 9% before from a different study. That of all plastic waste ever generated up to 2015, 9% had been recycled. Two different measurements. One is a single year's flow, the other is 70 years of accumulation. They land on the same number by coincidence. It's worth knowing they're not the same claim, because people who want to mislead you use them interchangeably.
And recycled itself has layers. In Europe, PET bottles are the success story. About 6 in 10 are collected. Roughly half become recycled PET at all, and only about a third of that flake goes back into bottles. The rest becomes fiber, strapping, trays, a step down, and usually the last step. Each melt cycle shortens the polymer chains. Bottle-grade PET needs an extra solid-state process just to recover the strength it lost. Aluminium doesn't have this problem, and that difference is about to matter.
Back to the can. It left the plant in a bale that sells for something between $1,700 and $2,500 a ton. That price is why every MRF fights to catch every can. Aluminium is what makes the plant's economics work. The bale is shredded, the lacquer burned off, and the metal goes into a furnace. Remelting aluminium takes about 5% of the energy of making it from ore. It comes out as a slab, is rolled into sheet, and can be a can again in roughly 60 days. There is no chain to shorten. The atoms don't care how many times they've been melted. Where cans are collected, they stay in the loop. Of the cans the US does recover, nearly 97% go back into cans. The catch is the first gate. The US consumer recycling rate for cans fell to 43% in 2023, the lowest since 1990. In Europe, it's 76%. The material is perfect, the collection isn't.
Glass and paper sit in between. Glass is endlessly remeltable, but heavy and cheap. Mixed-color cullet in the northeastern US traded at a negative price in 2024, while Europe recycles 3/4 of it. Same molecule, different collection system. Paper fibers survive 5 to 7 cycles, then they're too short. In Europe, packaging recycling rates land like this: paper 83%, glass 75%, metals 75%, plastic 41%. And remember, that 41 is packaging only, and part of it is exported and counted as recycled.
Now the last gate, the one you can't see from the bin: demand. Recycled plastic competes with virgin plastic, and virgin plastic is made from oil and gas. When oil is cheap, new resin is cheap, and a washed, sorted, imperfect bale looks expensive next to it. Recycled PET usually costs 10 to 20% more than virgin, so bales pile up, prices fall, and plants sell where they can. For 20 years, the biggest buyer was China. In January 2018, China closed its border to almost all imported plastic waste. imports fell 99% in a year. Bales went to Malaysia, Vietnam, India, Turkey. In 2021, the Basel Convention made mixed and contaminated plastic exports require the receiving country's consent. Turkey briefly banned imports of polyethylene waste in May 2021 and reversed the ban 2 months later. In 2024, it was again the largest destination for the EU's plastic waste, over 400,000 tons.
Add it up, and you get the real number that matters. Of the 460 million tons of plastic made in 2019, about 6% came from recycled material. 94% was new.
Chemical recycling, breaking plastic back into oil or monomers, is often presented as the fix. Today, it processes a small fraction of a percent of waste, and independent estimates of how much comes back as new plastic are low and contested. Maybe it matures. It hasn't yet. So here is the model. Whether something is recycled is decided at 5 gates, and you can read them off any package. 1. Is it collected? Does a bin and a truck exist for it? And did you use them? 2. Is it one material or several? Multilayers fail here. 3. Can a machine see it? Is it a known polymer? Not black, not film. 4. Is it clean enough and the right color to make a grade someone buys? 5. On the day it arrives, is that grade worth more than landfilling it, against the price of oil? The can passes all 5 almost everywhere. A clear PET bottle passes them in some places, in some years. A black tray, a crisp bag, a colored jug, mostly don't, and no symbol on the bottom changes that. The number inside the arrows is a polymer code. It was never a promise. Same bin, same truck, same building. Now you know why the can comes back, and the bottle usually doesn't, and it has nothing to do with how carefully you rinsed it. The bin was only the entrance.
There are systems like this everywhere, things we use every day that pass through machines and markets we've never seen. Next, we're following something else you throw away, and it goes somewhere you won't expect.